This video will go over Part D of the Google Sheets activity Scatterplots. What we're going to be looking at is how residual plots will look if your data is nonlinear. You're going to need the Treadware sheet to complete the following. So open up the Treadware sheet in your document. The data in this sheet is looking to see the relationship between the mileage in thousands of miles driven in a car and the depths of the remaining groove in the tread of the wheel, measured in millimeters. So the first thing we're going to do is to create a scatter plot, a linear trend line, and calculate the correlation coefficient. So you'll need to remember how to do that from the previous parts. So highlight the data, insert chart, and it's being smart, giving us a scatter plot. We're going to need to fix this up a bit with the units. So the horizontal axis title, the mileage is in thousands of miles, and the vertical, the groove, is in millimeters. So there's our scatter plot. We're going to need a trend line, so that is under series, a linear trend line. And the last thing we need to do is calculate the correlation coefficient. So let's move that down. Equals CORREL. Highlight the Y data, comma, highlight the X data, and you get negative 0.976. So it's a very strong negative correlation. So you can see from the value of the correlation, the coefficient is very close to -1, indicating a very strong negative correlation. However, if you take a look at the data, you can see that there is a curve to the data. In this section of the data, the points are still very close to the line, giving it a strong correlation that looks linear. But if you take a look at the graph, you can see that it looks more like a curve. Now, sometimes you want to wonder, is it a curve, or is that just the way the points look? You don't know exactly what's going to happen over here. You don't know exactly what's going to happen over here, but you have to make a judgment just based on what you see. So quite often just looking at the correlation coefficient isn't enough to see whether a line of best fit is the best choice. So now what we're going to do is to make a residual plot. So to make a residual plot, we have to calculate the residuals. So what we're going to have to do is to create the slope and the y-intercept and calculate the fitted values and the residuals. So we're going to get the slope, and that's going to be equal to slope, highlight the y's, highlight the x's, and the slope, of course, is m, and the intercept, of course, is b. That's equals intercept, highlight the y's, comma, highlight the x's. So those are the values that'll give us our line of best fit. So in here, we're going to get our fitted values and our residuals. So for the fitted values, remember it's y equals mx plus b. So you don't need to put the y, but there's the equals. The m is the slope. Make sure you make it an absolute reference, times the x value, which is 0, plus the intercept, and make it an absolute reference, and press enter, and you can fill this down. Those gives you all your fitted values, your residuals is equal to your actual y, subtract your predicted y. And those are your residuals there. So to make a residual plot, we're going to do the mileage and the residuals. Insert chart. It's not going to know that you want a scatter plot, usually when the two columns aren't side by side. So under chart type, we're going to pick scatter. And let's label it. So the chart title is Residuals Residual plot of groove versus mileage, and horizontal axis, that is our mileage in thousands of miles, and your vertical axis is residuals, and there is your residual plot. Now when you look at a residual plot, if you see a distinct curve in the residual plot, that will give you an indication that a line of best fit was not the best use, or not the best trend line to use for this data. You're not in this course responsible for doing anything other than a linear trend line, but this just gives you an idea that sometimes a linear trend line isn't the best. If you were interpolating, so using predictions within this, the points aren't that far away from the line, but if you were to extrapolate way out here, the line's going to continue out here, but the curve may continue this way, or might even go back up or something. So this here tells you for sure that those points are forming a curve, and a trend line is not, or a linear trend line is not the best idea. And that's what this paragraph is saying here. So that's really all you needed to know for Part D. Is if you are questioning whether or not data is linear or nonlinear, looking at the residual plot will give you a clearer picture.